Oscar, what are you doing? We're on air.
Oh, I'm just writing jokes, trying to make stand-up comedy my side hustle.
Okay, let's hear it then.
Why can't a pirate recite the alphabet?
I don't know. Why?
They spend years at sea.
Boo!
Okay. How about this one? Which poet loved earthquakes? Shakespeare!
Oscar, you may have your work cut out for you, but perhaps that's why they call it a side hustle.
Perhaps. Speaking of earthquakes, though, have you heard about the thousands of earthquakes hitting an island on the coast of Portugal?
Is this another one of your jokes?
No. This is real. Let me tell you more. The island of São Jorge, which is a part of the Azores archipelago off the coast of Portugal, was hit with nearly 27,000 earthquakes in the span of 2 weeks. And they didn't stop there. I know what you're thinking. Oscar, how is this island still standing after thousands of earthquakes? Well, the quakes were relatively small, at a magnitude of 3.8 or below. The nearly 10,000 residents of the island could feel some of them, but no major damage occurred so far. Seismologists, aka earth scientists that study earthquakes and residents of this beautiful island are concerned about this abnormal activity. Not only because of the number of earthquakes, but because this island is home to a volcano. The fear is that these earthquakes will cause the volcano to erupt.
Hold up. How can earthquakes cause a volcano to erupt?
By making the volcano mad! Okay, that one was a bad joke. I'm not 100% sure how earthquakes are connected to volcanic eruptions, but I know who does. Let's now head to Trenton for this week's edition of Next Gen Science.
Hey Next Gen viewers, Trenton here for a moving edition of Next Gen Science. Today we're talking earthquakes, how they happen, what they do, and how they can sometimes trigger volcanic eruptions. But first, I want to start with a question. Have you ever felt an earthquake? Living in California? I sure have. The ground beneath you starts to shake and at first you're like, what's happening? And then as the tremors continue, it hits you. It's an earthquake. But what exactly causes an earthquake? Secure your loose belongings and buckle up as I explain this geology lesson. The Earth is like a fancy rainbow TikTok cake. It has layers. The innermost layer is the inner core, then the outer core, followed by the mantle which makes up the majority of Earth's mass. And the outermost layer we live on, Earth's crust. And finally, one more fancy vocabulary word you need to know for now is the lithosphere, which contains the upper mantle and the crust. You could think of it like the Earth's skin. To understand why earthquakes happen, we're going to focus on the lithosphere. The lithosphere is made up of many pieces, kind of like a puzzle, but unlike a puzzle that sits on your coffee table, these pieces are moving really slowly, sliding past each other and sometimes bumping into each other. The technical name of these puzzle pieces is tectonic plates. Tectonic plates are responsible for Earth's landforms, such as valleys and mountain ranges. But for now, let's stick with earthquakes. As I said, these tectonic plates are always in motion, slow motion that is. The edges of the tectonic plates are called plate boundaries. Along these rough edges are fault lines, and most earthquakes occur along these fault lines. You see, when tectonic plates slip past each other, the edges of the plates will get stuck, as the rest of the plate keeps moving, causing friction. Friction is the resistance of one surface passing or pushing against another. In this case, there's friction between the tectonic plates. Finally, when the plates have moved far enough, the edge of the fault line jolts loose, overcoming the friction, releasing energy, and the result is an earthquake. Imagine two sumo wrestlers locked in a battle trying to push past each other. At a certain point, one of them is going to give in to the friction, releasing energy as one falls over. In this case, the sumo wrestlers are two tectonic plates trying to push past each other. But enough of the analogies, back to the earthquakes. When the tectonic plates overcome the friction and energy is released, it radiates outward from the fault in all directions in the form of seismic waves. Like ripples in a pond, these waves move outward from the epicenter of the fault and shake the earth. Powerful earthquakes can wreak havoc to roads, buildings, and other human structures up above. Scientists use seismic waves to measure the size or magnitude of earthquakes with a tool called a seismograph. The smaller the seismic waves, the smaller the earthquake, and you guessed it, the larger the seismic waves, the larger the earthquake. Earthquakes happen all the time along the fault lines, often in the middle of the ocean or at small magnitudes so humans can barely feel them. As I mentioned, I live in California. California is prone to earthquakes because it is located on the San Andreas fault line. I myself have only experienced earthquakes with a magnitude of 3 or 4.0, but the magnitude scale goes up to 10. Some earthquakes in the past have been completely destructive, such as the 2010 Haiti earthquake with a magnitude of 7.0, the 2004 earthquake in the Indian Ocean with a whopping magnitude of 9.3, which caused a tsunami, and in 1975, after a 7.2 magnitude earthquake in Hawaii, the Kilauea volcano erupted. Which brings us back to Giovanna and Oscar's original question: how can earthquakes cause a volcano to erupt? The word here we need to be careful with is cause. While there have been volcanic eruptions following a nearby earthquake, the United States Geological Survey says that volcanoes can only be triggered to erupt by nearby earthquakes if they are already prepared to erupt. This requires two things: 1, enough eruptible magma within the volcano, and 2, significant pressure within the magma storage region in the Earth's mantle. We have a whole Next Gen News video about how volcanoes erupt, but here's a TLDR animation to show you what we're talking about. The mantle is made up of solid rocks rich in magnesium and iron. Intense heat and pressure in the mantle causes these rocks to turn to liquid magma and rise. When this hot liquid magma rises and pushes through Earth's crust through a fissure or a hole, volcanoes erupt and lava flows onto Earth's crust. Now let's rewind and see how an earthquake could be involved. If the pressure is too low and the rocks are in a solid form, an earthquake could not lead to a volcanic eruption because the solid rocks are too heavy and would not rise to push through the surface. However, if the pressure is high enough and the rocks are in a liquid magma form before the earthquake happens near that volcano, then it is possible that the earthquake could trigger a volcanic eruption. Bottom line, earthquakes and volcanoes are both natural phenomena related to the mantle and the lithosphere. There have been some past instances where volcanic eruption followed a nearby earthquake, but the conditions had to be just right. Well, that's all the time we have. I'm Trenton, and thanks for tuning in to Next Gen Science.
Whoa, thanks, Trenton. But now I want to know more. How do earthquakes trigger tsunamis?
They happen under the sea, under the sea.
Is this a joke for your stand-up comedy routine, or are you for real?
Jokes, life, it all shakes together now.
All right, Next Gen viewers. Looks like we owe you a tsunami story soon.